All right, so we're going to continue on in adding and subtracting rational expressions. But today we're going to look at rational expressions that do not have a common denominator. So adding and subtracting rational expressions, but a little bit more work this time. So for our first problem, we're going to have x plus 3 over 5x minus 4x minus 2 over 6x. So the first thing I'm going to do when I look at these problems is I need to figure out what my common denominator is going to be. So if I look at this, both of those denominators have an x. So I know that my common denominator needs to at least have an x in it. And then if I look at just the 5 and the 6, I have to think about what number both of those could divide into. And those could both go into 30. So my common denominator is going to be 30x. So that means that my first fraction is going to have to multiply by a 6 to make sure that that common denominator is there. So I'm going to say 6 times x plus 3 divided by 30x minus, and then over here I'm going to say that this has to multiply by 5 to get that 30x. So minus 5 times 4x minus 2 over 30x. All right, so now I can go ahead and write this as one fraction with that common denominator of 30x. So I have 6 times x plus 3 minus 5 times 4x minus 2. And I'll go ahead and do my distributing. So I've got 6x plus 18 minus 20x plus 10. So 6x and negative 20x makes negative 14. And 18 and 10 makes 28. So it looks like I can take out, 14 goes in both. Negative 14 times x minus 2 divided by 30x. And then the 14 and the 30 can simplify a little bit. You can divide 2 from both of those. And so I have negative 7 times x minus 2 over 15x. And if you want, you could take that negative 7 and distribute it and get negative 7x plus 14 on the top, or you can leave it just like this. All right, example 2, we're going to have 3a over 4ab squared minus 2 over 5. So again, we're going to come up with the common denominator first. So we have an ab squared, and this one doesn't have any variables, so we're definitely going to need the ab squared. And then we have a 5 and a 4, and we have to think about what number both of those would go into, and that's 20. And so for the first fraction, to make this become 20ab squared, we're going to need to multiply by a 5. So I'm going to have 5 times 3a, and then 5 times 4, there's 20ab squared. And then over here, for the 5 to become 20, we need a 4, and then we also need all those variables. So we're going to have 2 times 4ab squared divided by 20ab squared. All right, so we have that fraction. We have 20ab squared. Up here, 5 times 3a. Since these don't have any distributing, I'm just going to go ahead and multiply them right now. So 5 times 3a is 15a. 2 times 4, that's 8ab squared. So now I just need to see if I can factor the top at all. And if you look at the top between 15 and 8, there's not a number in common, but between a and ab squared, you can definitely factor out an a. So I'm going to say a times 15 minus 8. That would be b squared since I took out the a. And then on the bottom, I have 20ab squared, and the a's will cancel. So 15 minus 8b squared over 20b squared would be our final answer. And we know that we can't cancel those b squareds because there's a minus right here. So subtraction problem definitely can't cancel those, even though it's tempting. All right. Another example. 2/3 minus 5x plus 5 over 3x minus 15. So with this one, you can see that this denominator is a little bit different than the other two. So these two denominators were monomials. They were just one term. This denominator is a binomial. That's two terms. And so I want to think about what this denominator is factored. So it's like you could factor it using a GCF, and I took out the GCF of 3, and then x minus 5 is left over. So both of these denominators have a 3, so I'm definitely going to want that in my common denominator. And then this denominator has the parenthesis x minus 5, so I'm going to need that as well. So to fix my first fraction, it needs an x minus 5 to have that common denominator. And so I'm going to take the top and multiply that by x minus 5, and take the bottom and multiply it by x minus 5. And then the next one, I'm going to go ahead and just leave. 3 times x minus 5. Okay. So I've got 3 times x minus 5 for my denominator. For the top, I have 2x minus 10, and then this negative needs to go to each piece. So minus 5x minus 5. Okay, so at this point, I have 2x and negative 5x makes negative 3x. Negative 10 and negative 5 makes negative 15. On the top, I can factor out a GCF of negative 3, and that leaves me with x plus 5. And I can see these 3's are going to cancel. It's going to leave the negative behind, but the 3's cancel. And then I have x plus 5 and x minus 5, and if I want to cancel those, but I can't because they're not identical. So I have negative x plus 5 over x minus 5. I'm going to say that's my answer. If you want to take that negative and multiply it back through in the problem, you are welcome to do that, but it's not necessary. All right, I'm going to squish the next problem in here. So here's our next example. We're going to do 11p minus 4 over 6p squared minus 3p. And we're subtracting off 4 over 3p. Okay, so again, when I do this problem, I need to think of my denominator in the factored form. So this would be 3p times 2p minus 1. And so my common denominator definitely has a 3p in each of the terms, but it's going to need the 2p minus 1. It's going to need that parenthesis. So my first fraction is just going to stay the same. But my second fraction, it has the 3p, but it needs the parentheses. It needs the 2p minus 1, so it will be the same. So I'm going to multiply by 2p minus 1 on the top and the bottom. And so now I can go ahead and write this. I've got 3p times 2p minus 1. And then this is 11p minus 4. And then I've got minus 4 being multiplied by 2p minus 1. So I'm just being careful when I have a subtraction problem and a number to distribute. I'm just going to go ahead and write it. So I know that it takes a little bit more space to do it, but I'm more likely to get the problem right if I'm being careful. So let's go ahead and carry this up here. I have p minus 4, and then I've got minus 8p plus 4. So my 4's cancel out. 11p minus 8p is actually 3p. And then what actually happens is the 3's and the p's cancel, and so we're left with 1 over 2p minus 1. Okay, we're going to do one last example. 1 over 3 minus 3x minus 6 over 6x squared minus 12x. So again, I'm going to go ahead and factor this denominator, difference of squares, and you'll notice that that's very common for the problems that I'll be giving you, is that they'll have a binomial on the bottom that you'll have to factor using GCF. I can't remember if I said difference of squares or not. I might have misspoken and said difference of squares, but I meant GCF. All right, so we have a 3 and a 6, and so I know that between the 3 and the 6 that both of these are going to have the 6. They're both going to have the x, and then they're both going to have that parenthesis x minus 2. So right now the common denominator is, in the second term, the first term needs a lot of different things. So for the 3 to become a 6, it's going to need a 2. It's going to need the x, and it's also going to need the parentheses. And so this part right here is what I'm going to be multiplying by on the top and the bottom. So I'm going to have 1 times 2x times x minus 2, 3 times 2x times x minus 2. The second fraction is just going to stay exactly the same because it already had that common denominator. Actually, I could have written this as just 6x. Okay. So 1 times 2x is just 2x. So I have 2x squared minus 4x. So for that first fraction, 2x squared minus 4x, and then I'm going to go ahead and say minus 3x plus 6. So 2x squared minus 7x plus 6 over 6x, x minus 2. And we can't cancel anything until we factor the top and see if there's some factors that would cancel. And the top is actually a slide divide problem. So I find two things that multiply to be 12 that add to be negative 7. And those two numbers would be negative 3 and negative 4. So x minus 3, x minus 4. The number that we slid was a 2, so we're going to say divide by 2, divide by 2. This can not be simplified. That fraction can't be, so we're going to bottoms up that one, 2x minus 3. This one can be simplified. There's our x minus 2. All right, so if I write the factors down, 2x minus 3, x minus 2, and then on the bottom we still have the 6x and the x minus 2. And what I can see is that the x minus 2's cancel. So 2x minus 3 over 6x.